So there are three words here. Can you guys see? Okay. Yeah. Okay. This is how I'm not going to have any PowerPoint, by the way. I didn't use PowerPoint. Well, I did have to use PowerPoint professionally. That's what banks do. Yeah, but I personally don't. No reason why you need to. Okay. So there are three words you need to know. One's big data, one's data analytics, and one is data science, and one is quantitative analytics. So, three words in the class. The name of the class is Big Data Analytics, right? So that's what Big Data and Data Analytics. Okay. Now, so what's big data? Okay. Big data is actually three things. It refers to three things. Okay. One is the very phenomenon. This is where when you Google big data, it's going to talk about the phenomenon of big data. What does it mean for humanity to now be in the age of big data? Okay. Second thing is when I said that's the reason why you can't really study big data in school, because big data is a technology stack, and that technology stack is very system dependent. And no matter where you go, if you're in a fintech, okay, some of the technology you won't have available to you. Some of them you have like a cloud deployment type thing. But if you work for a big organization, so young commercial bank, they have their own Spark infrastructure. You're going to have to learn it on the site, because the technical specificities will not be something that you can anticipate. Okay, that's what I said when I said, if you want to be a proper data scientist, you're going to have to deal with a lot of pipelining. And I don't mean scientific pipeline, I mean literal technical pipeline. How you get data based on system to talk with that system, and this thing is a live feed, this thing is blah blah blah, and how do you connect it together. So a lot of this is very technical, and believe you me, you're not going to be equipped to do it unless you have a proper software or computer engineering background. And the third thing that big data refers to is the premise of big data. Given that we are now in the age of big data, what is the world going to be like? What is your education journey going to look like? Okay? So phenomenon, that's when you look at and you check and see this thing. It's not very good, is it? It's pink. So next time can you guys see it okay? Yeah? Okay. The guy in the back said okay, so the girl in front has no complaint in that domain. Volume, variety, and velocity. Okay? Some people add things like veracity, and those are nonsense, and those are basic requirements. What makes really big data? Big data are the three things. Volumes. What do you mean by volumes? Lots of it. Okay? Lots of it. Okay? Sort of on the order of what, like maybe 10 petabytes a day. Okay? Things like that you have to process. Okay? It's the volume. It's the volume. Literally, it's the volume. Okay? Second thing is the velocity, variety. That means that you have to work with a lot of digital, but in terms of format, in terms of understanding, it's no longer the spreadsheet. It's no longer the text. It's all everything. Text file, Word file. Okay? Even what computers speak to one another, like we have internet protocol, that's computer speaking to another computer through some kind of messaging. Those also constitute data. Okay, those constitute data. Okay, so all kind of stuff. And finally, velocity. Now, velocity here has two meanings. First of all, velocity means the system has to be fast enough to ingest the data as they originate. In other words, you can ingest data fast enough so you don't have to throw anything away. That's the velocity. But a lot of velocity has to do with response time, meaning that the application is not just a one-way. It's not a storage. It's not just a retrieval, but also processing. And you need some kind of what's called low latency, meaning you have to be able to access big volume of data as a query. Okay? So those are basically the admin. Okay. Right. Now this part here, then I'll talk about the technology of big data. Okay. The first thing you need to know is that because the data got to certain level, it's one of those things where you can do 1, you can do 2, you can do 3, but you can't do 4. Okay? If you've got a mathematical introduction class, a little bit of mathematics or computing, you should understand what's called combinatorial explosion. Meaning something like if you deal with 1 dimension, it's okay. If you deal with 2 dimensions, it's trivial. 2 dimension, it's doable. 3 dimension, it takes some computer. 4 dimension, maybe takes supercomputer. 5 dimension, it takes the universe. So there is some unsurpassable technical limit to the computing paradigm. So the big data as a technology stack means you have to try something else. And that something else is parallelism. Okay? Meaning you don't do a big job by yourself, you chop out a little bit of job. Okay? And the predominant paradigm for that is MapReduce. Okay? Now, in the class syllabus, I've actually included the original seminal paper in there. You have the syllabus, right? Okay? The paper by Google, okay? That's the seminal paper on MapReduce. Now, read it for insight, but on the job, you're not going to use it that looks at remotely like that because it's being implemented in things like Hadoop Stack or Spark. Okay? So MapReduce is the concept, let's say. But in reality, you have to complementary, and actually they work together. It's not a competing necessarily. Sometimes they work together. But basically, you have Hadoop guy, you have Spark guy, and guys who are really good at that. And they're sort of like interoperating. So it's not one or the other. Okay? It's not one or the other. So that's the technology stack. Okay? Now, big data. Why are you guys coming in at 10 o'clock? Is. Yeah. So interactivity, like streaming, like real time, these are things that are coming into play. Yeah. In our class, because we're doing the analytics, which for the purpose of this moment, I'll just say analyzing for insight. It's not always something that you need a prompt response, but it's something that you need to do on a batch data. And finally, is ubiquity. Now, ubiquity means what? Ubiquity means it's everywhere, in the sense that this is everywhere, in the sense that computers are so cheap, you can embed a little chip into your purse, into your shoes, sort of the Internet of Things kind of thing. Okay? And ubiquity in the sense that once you have all these distributed units of computing, you have a protocol that allows them to talk together. So that's where network intelligence, network communication, robotics. I don't know if you've seen the YouTube video of drones that fly in coordination. If you program them, that's trivial. But if you give an algorithm to react to your neighbor drones, and that's more what I'm talking about. And finally, you have all kinds of remote sensing, satellite data, ground penetrating radar, all kinds of technology. So the premise is that, well, first of all, what is the big change? Let's get philosophical a little bit about this. The philosophical take is that human beings are different. Okay? What makes human beings the same as other animals? Just like any other animals, we consume energy. Just like any other living being, we increase entropy globally by reversing entropy locally. That's what an organism is, by the way. If anybody asks you what makes an organism, okay, you say, I reverse local entropy but increase overall system entropy. That's what you do. Okay? Why? Because as you grow up, you organize things into eyes, nose, ears, and throat. And that's very low order, very specific thing. But in order to do that, you consume vast amount of energy and increase energy in the system. You do that. You've always done that. Any animals do that. Okay. The difference now is that you now, in relation to digital domain, you have become the producer. Okay. Producer. You become the producer of data. Now, you don't produce in the old-fashioned way by, if you key in the questionnaire, that's producing data deliberately. Okay? But if you turn on your location sensitivity of your app, you actually generate data as you walk. Okay? So it's sort of like it's kind of like what comes first, the activities or the data. It's kind of both. It's once you measure the activity, your activities become data. Okay? So if you live your daily life, let's say you don't do anything different than 10 years ago, but you use your telephone. But your telephone is equipped with the sensing, the remote sensing capability of today. You haven't done anything different. You live your life as before. You already generate more data because there's a digital trail that you generate as you walk, as you talk, as you buy things. But then, not only that, you actively contribute, right? Because when you play games, when you look at YouTube or TikTok or whatnot, your activities actually contribute to more data than that was previously available 10 years ago. And they literally design software to trap you into speaking digitally to their application, right? So I don't, when I ask, say, for this class, a survey or something, that's deliberate, okay? But when I try to sense where you go, what you look at, let's say if there's a monitor over there, that's a facial recognition, all right? Actually, it doesn't have to be facial recognition, just object detection first. There's a face here, there's a face here, there's a face here, there's a face here. And I don't know how to grade class participation because there's so many of you and I don't remember. So I assign a little algorithm and say the percentage of time that you look up, that's class participation. I can do that, right? Because all it takes is what? One, well, I have to have recognition to know who you are, but I have to have the detection, and the detection has a framing that says you're looking up, looking down, right? Okay, so that becomes a sort of like a passive contributor. You are passive, but I'm active. And that's what big data allows you to do. So what's the premise? From data science perspective, the premise is that more data means more information. Okay? You have to keep that in mind because at some point, and professionally, I've actually run into those kind of points. When data don't give you information, everything you do from there on is invalid. The whole premise here that, oh, I gather more information, we give you privacy up for convenience, somebody knows what you like, you watch this on Netflix yesterday, you watch YouTube, and it gives a recommendation, you talk to your friends over line about buying a skirt and this type, this color, and the next thing you know, it pops up in your Shopee or Lazada suggestion, that sort of thing. Okay, and that's the sort of premise that they're going after. Okay, and to an extent, it's not, to me, it's not that creative. Okay, because it's the same game. The game is stoke your desire and sell you something. Okay, in marketing, it's called dopamine game. Right? Let me take 5 minutes to tell you what a dopamine game is. You know what a dopamine is, right? No? It's the happy chemical. It makes you happy. Guess where you get your happy chemical? When you get what you want? Well, not quite. You would think, let's say that, let's say you're thirsty. You would think that you're happy when you get to drink. Nope, you're not. Okay? That I think is oxytocin, different chemical. The happiness you get from getting what you want is very short-lived because the happiness you get from dopamine. Dopamine doesn't release when you get what you want. Dopamine releases when you're about to get what you want. Right? Why do you need that? Because dopamine energizes you. What's the point of energizing a lion? Once it's caught, it's prey. Nothing. Because once a lion has caught a deer, it can take its time. But the lion has to be energized when the prey is within reach. Right? Right? It's the hunt. It's the hunt. It's the expectation of immediate reward that gives you the dopamine. So you can say that the whole, I would say 95% of data science as it's applied in real life is about tracking the dopamine cycle. Okay? When you feel compelled to check for likes, right? It's not the happiness from the likes you get. Okay? It's not even the email. It's the picking up your phone to see if there's an email. That's what makes it so addictive. And you wonder why you keep buying more stuff, expensive things, and the happiness with getting that things only lasts a few seconds. Once you bought it, dopamine's done. Okay? Dopamine's done. I've actually tricked myself, actually. I give you a little funny story. I can want anything. You know, I want to buy a military jet. I can't buy a military jet. But let's say I pretend to buy a military jet. I just look through the brochure and blah, 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 and I'm going to get it. I can actually literally get dopamine from that. I never spend a cent. It's my way of tricking the dopamine engine. Well, most of you cannot do that. Most of you end up buying things. Okay? And then the dopamine goes for the next target. Okay? Next target. That's the delayed Gambibah type cycle. It's the loop. The loop is once you get it, the dopamine engine stops. It only works if you are about to get something. Okay? So most of that, so yes, the premise of data is information. At the moment, what kind of information? It's the information that allows you to track the dopamine engine, dopamine cycle. But wait a minute, you're part of Bachelor of Art and Science in School of Bachelor of Arts and Science Integrated Innovation. What about information that allows you to innovate sustainability solutions? What about that? Who's stopping you? So I would hope, even though your impression is that big data allows Lazada and Shopee to sell you things, and you think you want to do fintech so you can sell your, I don't know, computer games to a new group of maybe sell your games to retirees. That's a new market, something like that. So a lot of you have this kind of fintech, this kind of perception that with big data you can sell your unique things to unique audience. Okay? But you can think of it as well, this value information. There's nothing stopping you from having that information and solve real world problems. Okay? Global warming, that's going to require big data solution. Okay. All right, sustainability. So you have things like, well, things that are used to be natural disaster is going to have a higher frequency. They're natural to the extent that you don't have to man the triggers. but they're not natural because human being creates a condition in which they flourish. Okay? So you're going to need a lot of solutions in your life. And I don't mean this trivially. You will spend your life solving the problems that my generation created. Okay? So please don't get inspired by Shopee and Lazada. Okay? Think about what you're going to have to do when we are gone and you can't, play months anymore. Well, you could.
I wonder if we will give it.
No? Okay. Right. The other premise, now this is from a data science perspective, but from the analytics means if you have a lot of data, the tools with which you analyze have to become bigger. Basically, the task is more challenging. You have to expand your tool set. So your methodologies, the set of methodologies will have to increase. Okay? Now, so that's the three things of big data, data science, and quantitative analytics. Now, why quantitative? Okay. So I'm going to do that by kicking off your learning journey. This is probably the last time I'm going to talk like to you, talk to you, like a lecture, because it's an introduction. You are supposed to be project learner. Project learner. Now, let me get some things straight. Project learner doesn't mean you learn something from doing project. Okay? You're not going to learn anything from doing project. Huh? Project is a toy situation that you learn to do to apply things you already know. You learn something from the project, like how hard it is to get your idea across to your colleagues, things like that. What does working in a project environment looks like? You learn a little bit about how to control the pace, how to communicate the progress, how to maybe talk to your clients if you have, right? So that's learning about project, okay? But project-based learning doesn't mean you learn anything from the project. But the project is the setting that drives you to learn. And how you learn is a separate category. Once you get into the project, you will find out that you need to know this. But how you need to know this, and how you're going to know this, it could be from lecture, it could be from tutorial, it could be from online help, Python, how-to, YouTube. It could be from talking to your friends. It could be from reading seminal paper, original paper. It could be from reading applied paper, and then look at the bibliography section to see where the ideas come from, and look at that original paper that it referenced. Okay? So the project is what drives you, the direction, the pace, and the scope of your learning. Okay? But the project's not teaching you anything. Right? And maybe I'm not either. I'm just going to point you how to learn. This is something very nice. When I was starting my Ph.D., I kind of quote unquote prophesied. I said we started to have HTML at that time. Gopher, even precursor of HTML. And I sort of talked to my friend, in the future, you should be able to do your PhD at the beach, anywhere in the world, and get a degree from Imperial. Okay? And it's coming to be like that. It's coming to be like that. It's going to be like that. Right? So the first thing you need. Now, have you guys looked at the syllabus? Have you looked at anything? Okay. Well, the syllabus is my attempt at giving you a little bit of structure. So it's going to look something like 9 lecture-ish plus 6 sessions on project. But if we are going to be ambitious, it's not going to be ambitious. I'm actually going to shorten the lecture part. I teach you this and that to maybe even a third. And then immediately kick off the project cycle. Then, as the project proceeds, there'll be little topics that pops up. Then I can come back to lecture. I don't know. Does that sound better? It's going to be experimental, by the way. I've done traditional classes. Basically, I've done both in pure form. I've done traditional classes. I teach, I test, evaluate, right? Homework or not. And I've done project science, the data science project. I direct the research, the application from talking to the users, farming the data, blah, blah, the soft analysis. So that's really literally project, real project. And so, but I haven't done them in combination. So this would be a good experiment for me as well. So I might do that. So if you look at the structure of the class, say for example, if in the syllabus there's something about supervised learning on this subject, I may instead just give you half an hour on it, and then as different project uses supervised learning tools, I'll come back to those. I may do that, okay? So let's what's called play it by ear a little bit. So we kind of prototyping class. You guys are the guinea pig. It will be the first class, right? Am I right? Are you the first year, the first generation? Okay. I have this theory, by the way, that the blood gets thinner over time. So it could be that your next generation will surpass you, but it could also be that you're the best generation. So we'll see what happens. Okay. So we'll do a little bit of experimentation as we go along. Right. So we're going to have a little bit of conceptual understanding, and that's where the lecture notes. You got the PDF. Like for example, today for today I have a PDF, the scan of chapter 1 of this, and to help you look at the keyword, I think I highlighted a few, and you can look at that. This, by the way, is the best book I found on the subject. Because A, the guy knows what he's doing. B, he knows what it means for things to go outdated. So he tries to restrict the material not to specificities. Okay? But I disagree with him on one thing though, on the premise of data science. I literally see data science as science. But he only discussed data science from a technical job perspective. So it's not really aimed for you. It's aimed for those guys I mentioned earlier, the guys who are getting computer engineering degrees. Okay? Those are the guys that should read this. You should read this because you're going to be working with hardcore programmer coders and so forth. So I'll give you excerpts from various texts and so forth. Okay? So we'll talk about the art and science, business engineering, big data, all kind of stuff. AI, artificial intelligence, BI, business intelligence, and what my Ph.D. is computational intelligence, operational research. Okay, human learning, machine learning, what's the difference? Okay, where you are, the language. So these are the sort of like basically what gets you started. Now, once we get beyond that, we go on to the loop of the project. Now, with project, you have to set up a little bit by the team itself, right? The agents. Are we going to do this in a group of 5, group of 4? We have, by the way, we're going to decide that today. So that's on the agenda. Time frame, right? Technology platform. We're going to use Python. We're going to use Mathematica. If this thing works, and I teach again next year, I literally will require students to use Mathematica. But as this is a kind of short notice and Mathematica isn't free, it's not like Python, right? Python and R you can download today, and if you don't use it, you don't use it. But mathematics costs money, okay? But then your tuition also does. So, okay? Governance, supervision, how we're gonna run this thing. Governance, supervision, and the working is going to be agile. Agile is a different way of working, which everybody's using now. You usually you contract. If you have a specific job, I contract a programmer or a system designer, blah blah blah. It's called waterfall. So like please do this for me and see you in 6 months. Agile is more interactive. It's sort of like prototyping, and you involve the owner of the project so that project can change direction. And in fact, that is the first thing I want you to read from the excerpt, is how strong that loop back is. When you read the chapter, the excerpt from this book, I think the first thing he mentions is this back arc, this back arrow. Okay, that doesn't happen a lot with traditional, say, software installation projects, but it does happen in data science because based on the insight we discovered. I'm doing that right now in my consultancy job, which also Inat is helping at the asset management house. Some finding from preliminary study can literally change the course of the project. Okay? So you formulate a problem, you find something, you come back and you reformulate. Maybe the problem that you started with is not the problem you need. Okay. Right, so that's the agile thing. Now, it's not enough. You need these things. You need obviously project management, but this thing we can sort of like, monkey see, monkey do kind of thing. It's no problem. But definitely you need the mathematical foundation. Then you need to learn about the analytical engine. Now this is where I'm talking about the balance. Am I going to do the lecture for 9 classes, and then have you guys go at it for 6, or maybe have lecture just for 3, and then just come back as you need? Okay. So you learn during lecture, you learn during projects. We'll see. We'll see. Okay, but just give me a degree of freedom to play around with the syllabus. Okay. Now, you guys have to decide on the object of analysis. What exactly you're going to tackle? Okay. And you're going to tackle. A lot of times, they say something like, you learn something to solve business problems. Like say apply mathematics. You learn to apply mathematics to solve real world problems. And I was actually asked as an advisor for the design of the master and Ph.D. program last week, I think it was 2 weeks ago. And I said this, I said, never mind solving problems. Okay? Because solving problems is the final step anyway, right? Right? Can you imagine anything, any enterprise where you have a problem you don't solve? You're not finished. So it's not solving a problem. Applying mathematics is not about using mathematics to solve problems. It's about formulating the right analytical framework. Once you formulate it, say, as a system of equation, you solve it. Once you formulate it as a partial differential equation, you solve it. Once you formulate it as graph theoretic connection, you solve it. Okay? So the solving skill is not it. And that's the second point that is strongly emphasized here. What makes you a good data scientist is not the mathematics or programming skills. They are the requirement. It's not unimportant. It is so important that it's not the distinguishing feature. You have to be good in math, you have to be good in programming, end of story. But what makes you a good one, a useful one, or a useless one, is whether or not you can actually interpret the requirement, the situation, the data, the structure, the architecture, the application into analytical problem. Then, of course, you use the solution. Okay. Now, material resource, you have to decide what kind of data. Okay. Machine, presumably you guys have, what kind of things do you have? Oh boy, more maths. Okay, maths are great, but for maths to be computationally, basically math muscles cost a lot more money. So I assume that whatever you have is not very muscular. So, expertise, yeah, where you're gonna get that pipeline template. This means like how we design a data science project. Workspace, I guess you can sort it out. Never mind, that's struggles. So we have to sort that out today. Okay, we have to sort it out today. Now, once we have this, then we can cover the topics, and then we can look at the project menu. Okay. Now, the surveys, those are things like when I talk about data science, how it's used, the ecosystem, what I do. There'll be some of that as come along. Some application areas and use case. This is because I'm assuming that none of you have entered the industry, so you may not know what the reality of application looks like. Okay, so it gives you tools of the trade, that's like Python library, mathematical tools, and for. I'll give you a bit of war story since we've been fighting the war. The foundation mathematics. You only need two things in this class: linear algebra and lots of it. Differential calculus. Emphasis. Well, actually, it's calculus in general, but definitely differential calculus. Right? This forms the basis of everything. Okay? If you don't know linear algebra, you can forget machine learning. Okay? Your life is stuck. And then, of course, computer algorithm, and I'll give you guys a little bit about paradigm. This is something that computer kids are into. There's a functional paradigm, structured paradigm, object-oriented, and declarative. We're going to be using mainly functional. Python and Mathematica are very good at that. They can do object-oriented and so forth. My Ph.D. not only uses object-oriented programming, it uses part of object-oriented paradigm as a modeling tool. So I'm very much this guy, C++. Remember I told you that when I was in college as an undergrad, I wanted to not be good at computer programming. Well, the karma caught up with me when I was doing my PhD, because as a PhD student, you can't pay somebody to program for you. Okay? Well, if I had any money, I wouldn't pay them to program. I'd pay them to do laundry. That's the most painful part. Second is cooking, and finally programming. So I had to pick up programming. So I ended up programming C++. With user interface and whatnot, and it was object-oriented. But C++, C, these are very advanced stuff that since you're not a computer scientist, you just need to know about. Are we good? Pick it up. And did that class is here? And of course, background in mathematics and probability and statistics. Now, probability statistics is one of those things that I've taught since I was a kid. Well, not a kid, relatively young. Why are we still teaching probability statistics when we have machine learning tools? Well, it's because it's the cream of the crop. Remember I told you that when I was a master's student, operation research, and the lecture started with, given that we are searching over convex space, and I had this annoyance to say, what if the problem is not convex space? The solution is not inside a convex hole. How do we deal with that? Then you have to do something else, neural network. Well, the flip side is also true. If the problem happens to exist inside a convex hull, you'd be a fool to use other techniques. Okay? So probability and statistics are like that. They're the classical paradigm. Why do you need to learn it? Because if the data have well-defined statistical property, you'd be first-rate fools to use neural network. Okay? If the data is numerical, it's well-behaved, it has well-defined statistical property, has good convergence, fits all the tests, you'd be stupid to start using Python. Yeah. For Mathematica, you can use it. Mathematica has covered statistics as well. Okay? But instead of Python, you use something like SPSS or something, SAS or something. Okay? Because with Python, it's a general tool. Once you have the statistical results, you have plotting, you have to do all kinds of stuff. Statistical package comes already pre-packaged with that. Now, Mathematica also has statistical, so the statistical part I'll probably use Mathematica exclusively. Not SPSS or anything like that. Right. So you need to know probability, statistics. Those two, by the way, those two you need to know. One more reason why you need to know, because all the MBAs know. And at some point, you'll be hired by MBAs. Okay? Now speak the same language. Right, but MBAs will not know about Bayesian statistics, non-parametric statistics, and they might not care less about model evaluation, but you will model evaluation, you will care about it. Okay? And then, of course, we get to the meat of the stuff, which is foundation in machine learning. So, if the big picture is you're dealing with a lot of data and you're trying to analyze, that's data analytics. So analytics, I'll give you a formal definition that I came up with, which is any suite of methodologies, okay, that will allow you to turn data to information, information to insight, insight to decision making. Okay. So it is not one technique. It is a suite of them. It's like a toolbox. Okay. Analysis is what you do. Analytics are the tools you do that with. So when you study data analytics, there are a few things you can do. If you are a student, you just learn what is the standard toolkit look like. It's got this, 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 and this, and if the problem looks like this, you apply that. It's like an emergency medical kit. A headache, you take Tylenol or something like that. If you have cuts, you use betadine to wipe down that sort of thing. Okay? As you get more advanced, you have combination of tools. You use this tool to do dimensionality reduction, then you feed it into machine learning. Once you do this, then you map it to visualization. You do all kinds of complicated math. But you're not changing the tool. Maybe you are getting more advanced at the tool. And then you get the Ph.D., the guys like us, we try to actually develop the tools. Okay? The way we work is that when we look at a problem, we understand what this problem requires. And look at our toolbox, what have we got? Is it enough? If it's enough, we use it. We get congratulated on outcome. That's it, goes on. If it's not enough, then we have thinking process to say, well, can we adapt? And moreover, the adapting existing tool is a form of innovation. Can we then, quote unquote, patent this idea? Can we then own this invention? Okay? Can we make this a generalized version to solve yet other problems? That's the level we are. Okay, that's exciting business. Okay? So if I look at asset management data at the clients, and I look at certain manifold behavior of the data, well, this is a general problem, but nobody is talking about this kind of problem formulations. Well, you're going to do a PhD, right? So let's make this a subject. But the first thing you need to know is the basic tools that's already in standard toolbox. Now, the standard toolbox would not have the bottom three. Evolutionary algorithm, that's my PhD. Manifold learning, that's his PhD. Reinforcement learning, that's a lot of very interesting application coming up, but not yet, not for you guys yet. The standard toolbox that you're dealing with will be under two things: unsupervised and supervised learning. Okay. Now, unsupervised learning, we'll talk about clustering, how things group, distance-based, metric-based, density-based, data mining. These are things like, basically, this is the Lazada thing. Okay? Now, I keep telling you that Lazada and Shopee are not very interesting problems, and please don't be inspired by it. But having said that, it's so basic and it's so common that if you don't know about it or how to do it, you look silly. That's all. Okay? So this is one of those things where you need to know what, and sometimes it's useful, not always. So this is called, I call good old-fashioned data mining. Good old-fashioned data mining. Dimensionality reduction, and this is a very handy tool. This is like, you guys are, you're here, you're next to him, you are next to that person, right? I can see that, right? But that's location, that's only 3 dimensions. But what if in higher dimension, your preference, your taste, your behavior? There's also a closeness in that higher dimension. Well, in that higher dimension, you're going to operate. Can we reduce that to a lower dimension? Maybe even to show. So if I could say, everybody get out of the room, okay? And I want to say the new dimension is not where you were, but the new dimension is based on the BTS stop that you get on. So maybe if you live near a laptop, it'll be over here, and over here, and that's it. Okay? So the closeness is different. So that's where, you know, PCA, principal component analysis, variational autoencoding, TSNE, things come. Space embedding, this is another thing that's also very useful, self-organized map. So these are the meat, the bread and butter of and also I didn't put it here, but I'll put later, is things like natural language processing. Okay. So remember, I told you about closeness. You happen to be close because you're sitting close to each other. But what if I say you are a word, right? And I want to do something like the usual example they give is the word queen is close to the word king. But the word queen is also close to the word woman. The word king is close to the word man. So if we do some kind of language algebra, queen minus womanness plus manness should get king. Okay? How do I represent word in that mathematical space that allows this addition? Think about it. Yeah? Think about it. So if you want to, again, the mundane example is selling stuff. Okay? I want action movie, Netflix. I want action movie minus psychotic killers plus social dimension. Then maybe it's a drama about civil rights or something like that. Okay? You can do plus minus. Right? You can do word arithmetic, word algebra, that sort of thing. I'll put that in here, I'll correct that later. Now, supervised learning is what a lot of you will be based on. I separate into 4 categories. Shallow learning, things like regression type things. Ensemble learning, that's like if you have a whole bunch of little regression equations and use them together. Neural network learning, that's sort of state of the art when I was growing up. And then deep learning, this is where you add convolutional filter, you add some sort of internal state. This is state of the art. So we'll learn about that. So once again, these things we may cover This is what I promise. The things that we need to know in detail, well, you have three things. One is the mathematical foundation, get it with that. Second, the basic tools you need to know. Third, the advanced or specialized tools, you will know what they do. What I might do is actually for some of these, I just point you to YouTube. Right? YouTube is a great source of learning if you know how. Okay, so there's some YouTube channel that say, well, how do you differentiate PCA from TSNE? Okay, that'd be like YouTube for that. What's the nature of LSTM, long short-term memory node? That's a pretty good YouTube for that. So this gives you an idea of what they are, but not enough for you to do it. Okay. Now, here's the fun part. We have to think of the project. This is how you guys are going to be evaluated, by the way. I'm going to assign individual assignment, like find yourself a paper, give me a synopsis, find yourself a technique, describe them. Okay, it's a self-learning kind of assignment. So you have to prove to me that you learn. Okay, so everybody will have different subjects. We'll have to work a little bit about mechanism. Maybe there's in the line group, we have like a registry, so that I say, okay, go to this paper archive, and you choose one paper. Once you choose this paper, you just register. I choose this paper. Nobody else will choose that. Okay? So my guess is the first one really needs this paper from this side. Okay, but something like that, along that line, yeah? Something along that line. So you do personal synopsis. There's a very good website called Paper with Code. That's the tradition now. So you write paper and you keep the codes. By the way, Python, even though I'm not enthusiastic about the language, I am most admiring the community, the sharing spirit, the free code thing. You know, Mathematica is also allows you to share free code, but the program itself isn't. Right. So now you talk. Is there another microphone we can use? How many of you are there? 40? 5? How many? How many of you are there? Let's say 40, 45. Okay. Have you filled the survey question? Okay. Based on that survey question, well, I haven't looked at it, so raise your hand if you're good in programming. Just this room. I don't mean good for me, good for your friend. Like your friend can count on you to know a little more than. Come on, double check. False honesty is bad. It's a form of false honesty is a form of inaccuracy. If you're good, you have to be honest. I'm damn good at something. Say, you're good. You're good at what? Python, right? Python, macro, okay? Various degree, fine. Who's good in math? Okay, we have to figure out a way to get yourself sorted. Now, the reason I gave you a little survey question was I was going to try to, optimize you guys a little bit. Say, each team has one of each, or something like that. Guys good in math, so I can do that. Or would you guys like to pair up by yourselves? Speak. You want to pick your own team, or you want me to pick your team? Hello? Okay. Agree or not? Yes? Yeah? You pick your team? You know everybody already, right? It's the second year, so it's okay. You should know each other. Okay. Now, you guys will be peer review. And this is where it gets interesting. Let's say I give you a team of 10, let's say 10. Okay? You have a certain vote, and you have to vote who's more contributive. Right? Based on that, there's going to be a directed graph or a matrix. What I'm going to do is square this matrix. Then I'll feed this through eigenvector decomposition. And you will be given score based on eigenvalues. Okay? That's how you're going to be graded. And of course, it's only the project, so if you all, the project really sucks. Okay, just a little bit. It's just for fun. It's, don't be mean, be nice to your friends. The first thing I learned about project work is that be nice. Yeah? It's a win-win thing. It's either win-win or win-lose. You never have a win-lose. You never win at the expense of the other when you do a project. You either win when everybody wins, you lose when everybody wins. So be nice. Okay, so help each other as much as you can. Are you guys ready to spend the rest, say 5 minutes, picking up a team so I can get you seated? Okay, that's the thing. I need to know how many we have. How many? Well, wait a minute. You guys belong to the first year, first class, right? How many of you are in the first class? 200? 100? I don't know the range. No, I just want to know how big is the class anyway. Just curious. 80. Okay, and those this is an elective, so maybe half of you, about 40 or so. Say. Yeah. Okay, let's work with 40.
Right now we didn't have like the design.
Yeah. Okay, so let's work with. Okay, let's say a group of 7, maybe. Is that too big? Too small? Good enough? No, if anything, I like to make it smaller because the subject can be. Now, yeah. About group of, yeah, 4 or 5 sounds good. Having said that, let's go with 7 because if there are too many topics, then it's spread too much because I'm going to be teaching that. Okay, let's go with 7. Okay. Right. Now, what are the projects? Yeah, this is where you talk. I'm going to let you guys do some kind of crowdsourcing by yourself. All right? Anybody who feels an urgency or a particular need or a particular interest to address certain things. Say, I want to apply machine learning to find out about how well we recycle in our community. Okay? Now, are there people who are very driven to solve something or something itchy? I write down as where it itches, where's the itch? So if it's something like this, you can say, I want to do this. Who's with me? That's one way. Another way is to say, well, let's form a group. I don't care, form a group. let's go to Kaggle. Kaggle is a data source, Mathematica is a data source, and work with this data set and see what we can work with. Okay, that's sort of like looking for the problems. The other is to say, okay, as it me, myself, I have lots of questions that I haven't answered. I haven't had time to answer. Okay? If you want to solve them or you want to answer them, you come to me and I give you the hypothesis or the question condition. Okay? And then I'll act as your supervisor throughout the projects. Now, this is where I'm looking for initiative from your side. Okay, let me take a coffee break for myself. You guys have a little bit of chit chat. Maybe separate room, have different chit chat. And see what you can come up in 5 minutes. Then I'm going to spend the rest of the class giving you a little tour of Mathematica. Okay?